weeks, and I was thinking to try something new today. I've been streaming coding, playing games, although it was one time for each. Though I haven't streamed myself working on videos. So I thought of doing that, but I'm still at the one of the hardest parts really. That really is the one that goes the slowest out of all workflow, because I'm obviously talking about the script. I haven't finished yet. I haven't finished it yet. It's mostly because I've been busy with school stuff really. But now I want in this stream to finish my script. Why is this important? Well, without the script I won't be able to record. So today I will try to finish the script, and tomorrow I will record and start making the video itself. But first of all, I shall put the music on, shouldn't I? Because I'm not gaming or doing anything really, I'm going to use this song as my background music, because I like 8-bits music. And it's under Creative Commons Attribution License, so I hope it doesn't annoy me, because I can only hear the music, not myself too, or I'm really disturbed by hearing myself talking, aside from the natural stuff that is happening with the bones and that stuff. But yeah, so I have like 40% of the script finished. Actually not 40%, because it's like it's not even the first draft. I still have a lot of stuff to put, a lot of ideas to cover. But it's going well, I suppose. So what is this video going to be about, first of all? As the first line says, on 19th of March Nvidia announced RTX technology, which is basically real-time ray tracing. The idea of real-time ray tracing is not even close to being new, but there is certain stuff about the approach they took that is really new and exciting. This ray tracing technology, this way of how should I put it? In order to obtain a good image, you need a lot of samples, and as you've surely guessed, a lot of samples means a lot of time. It means that it takes a lot of time to render a frame. I can show you this in Blender right now. But usually when you have less samples, this problem appears, noise appears inside the image. I'll show you right now what I'm talking about. As you can see, this has no noise, unfortunately. Let me make this lamp a lot more powerful. Like use nodes. It's not seeable. I should maybe put a material on this guy. This nodes. I will. Noise is actually best seen with a glossy material that is rather rough, but not really rough. It's annoying. I will use another scene I have already in my computer. Open recent, I don't know. Let's use this. This is actually a good example. It's a scene of smoke. And it crashed. I wanted to show you what a small number of samples mean for the actual image, that is the actual rendered image. The idea is that you need a lot of raycasts a lot of rays to have that smooth image that is really close to how it is in real time and how it should be. But the computers aren't powerful enough to actually render it, unfortunately. Right, so I'm going to... okay, that's okay. Render. Okay, so I'm talking about this noise. You see it? That is some noise there. I am using 42 samples. I'm not sure what samples means for Blender Cycles renderer, but I'm using 42. If I wanted to get rid of almost all that noise, I should go with a really high number, which increases the duration of the rendering by a lot. So this is almost real time. You can't argue with that. I mean, if it were like, I don't know, 10 samples, it would be almost real time. Let's actually make it 10 samples, like, leave it like 10. Let's actually make it 5. So at 5 samples it's really noisy. So the hype around this, so the idea that, the new thing that the RTX technology brings is a denoising algorithm. Denoising is really important in raycasting for this exact same matter, because, you know, having an image with noise, it's no good. So RTX technology brings denoising, but not any kind of denoising. Denoising algorithms existed for a long time. So, what kind of denoising algorithms does NVIDIA bring? Well, AI accelerating denoising. That's the deal with the new RTX technology and the new line of GPUs. Because this new line of GPUs actually have tensor cores, which are a special kind of cores newly introduced with this technology. And so newly introduced with this technology, and they are really helpful for AI applications. I'm not sure how AI applications work, but these tensor cores do fast matrix operations, which somehow it's helpful for AI. So that's the deal with this new series of GPUs, and that's why for ray tracing rendering, these new GPUs will be obsolete. They are not actually so powerful that they can render real-time ray tracing with a lot of rays casted with a lot of samples, but they have something new and something specific. And I suppose that's the reason Titan Volta costs a lot. It has these new tensor cores. So in the first part of the script, I am focusing on this new technology rather than, I'm calling this video the future of computer graphics, not because this will be how the future will exist from now. Actually, scrap that. Not because I think this is representative for the future itself, but rather because from this idea I want to speculate about how the far future of graphics will look like. I have a few speculations in those ideas, or in those bullet points ideas, but this along with physically based rendering, this innovation is really important in my opinion, because it really allows more realistic games. Though the games we have now are realistic too. You cannot say that, I don't know, go look on a new AAA game. You can't say that it looks fake. Obviously it looks a little bit off. Real trace rendering looks a lot better. And actually in some cases it will be able to do more things. I'm explaining in the video, although not really detailed, about what current type of graphics we have now, and this type of graphics that we have now in games is called rasterized rendering. This type of rendering means that the actual geometry is projected onto an image and then the image is manipulated. This is the most simple way of viewing it actually. And this is really truth to how it really works. But the shading, in order to do some advanced shading things like ambient occlusion, you need certain tricks, because you are working with 2D images, not actual 3D information in the shading pass. Ray tracing will allow ambient occlusion to look more realistic, and actually Nvidia had a good video showing this, which in my opinion it really shows the difference. It's this one, and it shows few scenes rendered with raycast rendering and then rasterized renderer. This is how ray trace looks. Look at these detailed shadows. These shadows look more realistic than they look in the current games for a reason. Now in the current renderers now use shadow mapping in order to simulate the shadows. The scene is rendered from the viewpoint of the light in order to obtain information about how the shadows are casted on or on what these shadows are casted. And with ray traced shadows, you can actually do other effects like this penumbra, which makes it look real and totally not fake. But the real difference is this: when it compares ambient occlusion, this ambient occlusion looks really fine. It is about here, yeah. So this is ray traced ambient occlusion, and skin space ambient occlusion looks really flat. This flatness is because of this limitation that rasterized pipelines have. Now, of course, this ability to actually have an AI accelerated denoising algorithm is really intriguing for this reason. It actually shows how AI can be used in multiple domains rather than just Amazon Echo or Google Assistant or Google Maps, I don't know. This is a really interesting practical use of artificial intelligence, but it's not like the actual artificial intelligence that is denoising. From my understanding, it's only accelerated by artificial intelligence. I'm not sure what does this mean because I didn't research, because I rather wanted to, inside this video, to present the overview of what could happen given this quite large step, I suppose. I mean, let's be honest, this AI accelerated denoise algorithm is really intriguing, and it seems like a welcomed innovation in real-time graphics. And imagine that this real-time graphics was powerful enough, was realistical enough to not exist a difference between how a realistic renderer looks and how a Pixar renderer outcome looks. This will actually help with with less time taken for rendering large movies. But of course, inside those movies, it's not only the graphics that matters, and that's what I will be writing about actually. Graphics is just a part of CGI. Of course, it's one of the most important parts of CGI, but physics is actually important too, and especially particle simulations and water simulations. Why are these important too? Well, imagine having I don't know, insert new science fiction movie here without explosions. Those explosions need to look like they are real. They don't need to look like they are real. They just need to trick your brain. But still, explosions inside games look a little bit flat, and that's for the reason that they are actually sprites. I don't know, but I don't actually know this, but I think it's safe to bet that these guys are actually making physics simulations for those explosions. So even though we reach a certain realism to our graphics, to our real-time graphics, I think GPUs should still advance, because the uses a GPU has are there are a lot of uses that a GPU can have, from AI applications to physics simulations, and maybe we will see some of those in games, some of these used in games. And I think despite of reaching a certain level of realism, games would still profit of those applications. You can't argue with the fact that physics is really important. So the idea, so I think that this part is actually written okay. I need to work on this part because I made it in a hurry. This is a wrong opinion. The thing about making videos like this is that they should be unbiased to a point, but they should prove a certain opinion, and they should make it really obvious that they are expressing an opinion. You don't want people to catch the wrong idea. So now I am trying to express my opinion about what is going to happen. Also, when writing a script, I try to keep in mind the pace and how I am talking. For instance, in the last videos I didn't manage to do that well, and that's quite obvious. But now I actually want to do it, and I want it to play a really important part. Up until now, I want it to be like rather I want it to be how to say it, rather uplifting, rather normal, like how my other videos are. They are, I guess you could say, plain, but in this part I want to add another layer of depth to the video, and another layer of depth to everything, so it seems less flat. Usually, I don't know, maybe I call it wrongly, but when I see it in other videos I refer to it as a breakdown, because it's like, I don't know, the graph of anticipation goes really down, and usually when I see it in other videos this breakdown in other videos is usually when a question really important to the video topic is asked, because up until now there is nothing to do with the actual title. I mean, sure, this is the future of computer graphics to a certain extent, but this is more about games and not about CGI in general. That's when I introduce. Also, this part is the near future. I want to talk about the far future. So As I said, here I will ask an important question. That's where the video will change the mood and the style. So as I have been trying to say for a couple of times now, this is where I will ask the question and the video will kind of change entirely. What question do I ask? Well, the question should begin with but or any other synonym of but. Maybe I'll find one later. Now, one thing that I have learned, I mean, you can't really say that I've learned a lot, but one thing that I have actually learned is that you need a good balance between essay style of writing and free talk, like informal talk, should I say. Why am I saying that? I'm saying this because sometimes with words that you would write in an essay, you are not able to convey what you are craving to convey, what you are striving to convey. You need to put certain emphasis on those words that are really important, and you actually need to put emphasis not only in your writing but in the voice over the voice thing of the video too. I am pretty sure that the script up until now is not okay, it's not good at all, but one thing that I am doing, and you should really do after writing your script, take a break and then come to it later, because you will feel more motivated to actually reread it. So this is where I am introducing the more extended topic. I have actually realized that what I have written here is kind of dumb. You shouldn't be afraid of writing dumb things. You should be afraid of letting those dumb things in your final product. Oh, also, you somehow need to continue what you are talking about. How am I going to get around this line? This music is kind of catchy. I'm not sure if it's too annoying for the stream itself. I hope it isn't. along with the addition of programmable shaders, physically based rendering, I don't know how to say, without any shadow of doubt. This is an important step in the history of computer graphics. I mean, I don't want to make it sound like it's biased towards how innovative Nvidia is and how less innovative AMD is, because there is a lot of fanboyism over these two companies on the internet. But I actually want to convey my idea. That's why I'm saying this part was really dumb. I'm saying this because I tried to keep too much this fanboyism in mind, and I forgot about making it actually unbiased. But without any shadow of doubt, this is an important step in the history of computer graphics. I don't think I want to say along with the addition of the programmable shaders. So, sometimes when I don't know what to write, I actually put this and I go to the next idea. This helps me to get the ideas going. Here I want to say this makes me wonder of what future holds for computer graphics. So now I want to convey the idea that I talked about earlier, that to some extent, I mean, I should research this more. Yeah, don't worry though, I will verify my script later. I can't stand to have actual errors inside my script, but now I don't feel like to do it, because now I want to actually have the entire structure done. Anyhow, what I want to write about here is what I talked about earlier. The amount of pure processing power and how it affects the time taken for, I don't know, let's say Pixar to render one of their animation movies. But I want to actually put in contrast the gaming part, because I think that inside this I don't know how to call it, animation industry, there is not much innovation, as many of this stuff is actually implemented. Computers are really powerful and they even have enough money to run it. So I really need to find a way to put in a positive light what means the amount of processing power and the amount of the amount of time it takes. I mean, just CGI is really advanced, and I really need to talk about it not only in games. I really need to contrast it. I mean, I don't necessarily need to contrast it with to contrast the advancements in gaming to the advancements in the animation industry. But I think, although I didn't proof check it, it's safe to assume that the innovations in animation industry is quite slow. I mean, the realism part of the animation industry, should I say. How do I put it? So now I will introduce raw computational power. It's not raw computational power, but the raw topic of computational power, like computational power is an important factor that enables the evolution of computer graphics. No. Now I need to introduce the fact that computational power increases by second. By second is way too cheesy. Unlike any video I've done up until now, which are actually just 2 videos, I've never tried to introduce ideas. I've actually just tried to explain stuff, which it's safe to assume that it's easier. So computational power is an important factor that enables the evolution of computer graphics, and along with time, computational power dramatically increases. I think this sounds dumb, but it actually gets my point across until I come back and make it better. Rendering graphics in games has seen a fantastic realism of graphics in games has seen a fantastic growth over the past decade. And to show this, let's see some images of Half-Life 2 that was last decade. Maybe it's a stretch. I don't know any game, but this is how Half-Life 2 worked. This is all basic stuff. I mean, it has absolutely no physically based rendering techniques whatsoever. They were way too powerful for that period of time. This is screen space reflection, which looks kind of plasticky, and these textures looks flat too, even though they have normal mapping to them, attached to them. And this is how games look now. An example of a game. I don't know, maybe let's go with Assassin's Creed Origins, for the reason that it has, I want in-game footage. This looks like it is in-game. Yeah, it is in-game. It actually doesn't look that nice. Shadow of War. Look at this. This is a lot more. There is a more detail to this scene. The models are more detailed. The textures make you. The textures are more detailed too. The shading is a lot smoother. And then from this, jumping straight to actually no, I just don't. I will not show anymore what I wanted to show. But actually, the addition of computational power allows for this thing, for more details too, which is another important part that I'm trying to convey, that I will be trying to convey rather. Has seen a fantastic growth over the past decade. Not only now I am trying to contrast not only in gaming field, but rather in animation industry too, although it presents a slower evolution, It is one thing that you would like to do after you introduce the fact that this is your opinion is that what did I want to say? What did I want to say? Oh, damn it. What I'm trying to say is that after introducing the fact that this is your opinion, talking at the third person is a lot nicer and it feels more, I don't wanna say deep, it feels better in my opinion. It is safe to assume that the future increase, you don't really want to use the same term multiple times in the span of a few lines, so let's check for some synonyms of the future. Fortune, doom, fate. The future increase. I'm actually looking for. Yeah, I could use the much anticipated increase. The much anticipated increase of computational power expected. That will occur over the next couple of decades. if you come to think of it, in the last 20 years, 20 years ago, actually exactly 20 years ago, Half-Life 1 was released, and now we can render amazing worlds at real time, amazing worlds with detailed environments and a lot of realism. I think I will laugh really hard after I finish and rewatch some parts of it, but whatever. So that will occur over the next couple of decades. Will play not will play an important role. Oh yeah, actually what I can do, instead of having the breakdown in quote breakdown and quote here, I could put it here, but what will happen when asking what will happen when the realism, the growth of realism will be so unnoticeable that we'll have to redistribute the computational power to other areas, especially inside a game, which is where I could introduce what other stuff will be done with games, and I don't know, I will see what I come up with. But there are a few ideas that I really want to talk about and that I really should talk about. So it is safe to assume that the much anticipated increase of computational power that will occur over the next couple of decades will bring with it a lot of realism. Will bring with it more detail and realism to entire worlds. This is referencing to games. Will bring with it missing words here. Will bring with it more detail and realism to entire worlds. So now will bring with it more detail and realism to entire worlds. And not only in games, as this computational power, this increase. Actually, I shouldn't say this increase in computational power, because it's really flat to say this. Because if you buy a lot of graphics cards and if you buy a lot of graphics cards and just make a render farm to play your game and find a way to distribute that stuff, yeah, I think I should really I need to bring inside the discussion the how was it called? That thing. I actually can't remember a word. Yeah, I can't remember a word, and it's not like I can search it because I can't remember it in my language either. Why does this happen to me? Going on. I'm going to go on with this. I will leave a couple comment here. Alright, so this is the bridge actually. The bridge from computational power talk to what can happen with this computational power. And this is where I'm introducing the new ideas. I will first have a rough I'll copy a few ideas. Oh, I should talk about this too because this is really important. But after I introduce the ideas, I should talk about it. Now, if you are wondering how many pages do I need in order to make an over 10 minute video, the one about the history of computer graphics had like 5 pages. Type of games that are currently produced. This is vague, but I actually know what I meant with it, because not all games focus on realism, and a lot of games focus more on the art style and other perks. How computer graphics trends tend to evolve. I'm correcting ideas, yay! What it means for the future, speculate about the future. Yeah, that's VR is big and has just begun. Through adoption for VR. Actually, I want to talk about this. When was VR launched? I think in 2016. VR debut. No. VR goggles. Okay, let's check this one. 25 and present. By 2016 there were at least 223 it doesn't sound so. 230 companies developing VR related products. Facebook has 400 employees focused on VR development. Google, Apple, Amazon, Microsoft, Sony and Samsung all had dedicated AR and VR groups. Dynamic binaural audio was common to most headsets released that year. However, haptic interfaces were not well developed, and most hardware packages incorporated button-operated handsets. I want to know where in 2016 virtual reality technology debut. I have no idea how to read this word. Yay! Debuted with the launch of two mainstream VR goggles. Were they already too? I don't know, but I know that the hype was generated by them, hopefully. Yeah, I think it's safe to assume that. I mean, if you watch the trends of, I don't know, Linus Tech Tips, it's safe to assume this. To mainstream VR goggles. This technology requires I forgot another word. Such an amazing day, isn't it? A nice day to forget words. This technology lacks of actual immersion. I don't know where I'm trying to go with this. I don't think it's going anywhere. So I will scrap it. Maybe I can use it. Haptic technology and audio art and natural audio simulation are two areas in which this technology this technology is lacking. I'll find a better word, don't worry. Increased computational power will allow I don't know if audio is one thing that I want to talk about, because at some point I have seen, still from Nvidia, it seems like Nvidia are the one that actually try to push the boundaries of current technology, and Intel too, I think, because AMD seems like they are trying to push the boundaries in the other way. By providing competition at especially prices. Nvidia audio simulation, I don't know how to search it. I think VR works. Okay, truly immersive audio to application by path tracing sound in 3D space in real time. Path tracing is an important word in this case. Path propagation, path traced audio. This is one place where this kind of architecture that GPUs have really helps. How sound moves in space, modeling propagation. I mean, these areas, you don't need to care about these areas because they are indirect to this fully GPU accelerated and path traced audio solution that creates a complete acoustic image of the environment in real time without requiring any pre-computed filters. As the scene is loaded by the application, the acoustic model is built. Yeah, that looks nice. Let me try this. Are not only helpful for graphics anymore. Not only they provide resources for areas such as only they provide not only they provide they also are useful in fields. I'm not planning to let this in my video, but I'll just write it because I have not even a slight idea of how to actually rephrase it in this moment. They also are useful in fields such as medical research, AI research, weather prediction, and many more. This music is quite catchy. But immersion in games and even movies is another entire topic. Immersion Immersion. Okay, now I should give immersion. The definition of immersion, which is immersion therapy, baptism by immersion, immersion games, immersion mathematics, I think I definitely should have nope. Not this one. Yeah. Here I check how many pages I need. I need 4 actually. And there's another entire topic. Immersion is the act of fooling stimuli, of tricking human mind by providing fake stimuli. Simulated stimuli, that doesn't sound right. By providing crafted stimuli, maybe. Seems like it's working in this context. By providing crafted stimuli. Yeah, it sounds okay, I suppose. So I want to talk about, I don't want to do another list there because I won't follow it at all. So increase power without to stimulate what I'm not here. By providing crafted stimuli. And some cases this stimuli not a lot of require in some cases these stimuli require I actually need to give examples from the real life that will hold what I'm saying into place. The stimuli require a lot of just as graphics does. Power in order to be rendered with quotes. I will actually include this. Audio is is just as important as graphics. Effects in order to full human mind to be immersed. There we go. Mind to be immersed at I want to say something about the fact that light and audio behave the same way to some extent. Okay, to some extent audio and sound and light behave the same, and for this exact same reason NVIDIA can be rendered with the GPU itself, no comma, with similar algorithms that exist for simulating lighting for simulating lighting. When was this? This one. Audio Works NVIDIA. When did this thing appear? It has no date. Let me just go the hippie way. I'll just go on this site, search when is the earliest archive and see if it corresponds with the developer page, which was made on 2017, July 2017. This is when it started existing. So it's 2017 and no earlier, which is okay. In 2017, NVIDIA introduced Audio VR Works which is a path trace audio renderer. (2016), whoops. I should actually I don't want to see that NVIDIA introduced it. Oh yeah, also what I want to say is current papers and speculations are the technology of tomorrow. Are when I will give examples about this machine learning, quantum computers maybe. Ray tracing should be one of them. Also, I should research about computer graphics papers. Okay, that's what I'm trying to search. 2017, simulation of subseismic joint and fall networks using a heuristical mechanical model. Repurposing hand animation for interactive applications. This is boring stuff, or at least seems like. Interactive detailed cutting of thin sheets. Okay, this is some good stuff. We are getting into the let's see technical papers of 2018. What? No. Technical papers of 2017, because SIGGRAPH 2018 wasn't held. Technical papers first pages. What? Art papers, resources for computer graphics. Computer graphics papers. Alright, find computer graphics research. Graphib is a searchable database of more than entries of computer graphics research from scholarly journals and conferences proceedings, available academic. So I am on this website. Alright, I am going to search this on Google. Energy saving color scheme for direct volume rendering. 2016. High quality illustrative effects for molecular rendering. This sounds interesting. Article, author, title, pages, year. So I actually can search by year. If only I knew SQLite free. Article URL. Well, it seems like I won't be able to purchase. Why? I want open source stuff with hardware tessellation, practical low-cost recovery of spectral power distribution. This stuff sounds really fancy. I hope it doesn't redirect me to the same thing. Alright, so PDF, that's what I want. Institutional login. Thank you. So I need to log in order to download it. Register. I think I have to buy it. No, thank you. Alright, let's. I actually don't want to say that current graphics is. I mean, there is not much improvement to current graphics, because it seems like it's not real and improvement can be made. But I actually want to base this off real papers that propose some improvements or other improvements. But seems like I would need a lot of time to actually research this topic, so I wanted to have this video done by this week. Accurate and analytic approximations, real-time rendering of procedural mass, multi-scale materials. This doesn't seem to be a stochastic and scalable approach for real-time global illumination. Adaptive deferred shading. This thing is it's rasterized rendering. Progressive streaming of texture 3D models in a web browser. I am trying to find abstract papers, not applicable papers. That's A planar quadratic clipping method for computing a root of a polynomial in an interval. Yeah, sure. A binary accelerating structure for fast isosurface rendering on GPUs. This doesn't help me at all because it's applicable with today's technology. I am trying to find a field or speculation or something like speculation. Yeah, it's a good word in this. Improve gloss depiction using the empirical highlight and distortion method for 3D image warping based stereo rendering. No, thank you. Procedural bread making. I don't know what bread it's talking about. So, as an ignorant guy, I will just laugh at it. It seems really funny nonetheless. 3D Heritage Online Presenter. Parallel resampling method for interactive deformation of volumetric models. I am trying to find a hook. How animated movies are rendered. I'm not looking for this. Nah, I should have access to this with. Yeah, that's better. No ads. Lots and lots of cores. So making an animation movie is like swimming across the English Channel, difficult and exhausting. The idea seems almost ludicrous. How do you take a story idea and render 2 hours of footage from pure imagination? Finished films such as Shrek might look effortless, but they involve countless animators and rendering artists. And more than anything, animating films test the power of modern computers. No? Sherlock. Recently, Tehradar visited the DreamWorks animation studio near San Francisco and met with a group of technicians. The goal to find out what kind of computer horsepower they require. Yeah, sure. On a system with 32 gigabytes of RAM and 160 gigabytes of SSD boot drive and a 500 gigabytes data drive with an NVIDIA Quadro 5000 graphics card, which itself has 352 cores. A technician opened an animated sequence for a new character in an upcoming movie. DreamWorks set up a demo between HP Workstation Z800 and HP Workstation Z820. These systems are similar, but Z800, whatever, one has 8 cores, the other has 16. The character sequence consisted of 16 frames of video and both rendered in just 10 seconds. I am doing something wrong, I think. It takes me a lot of time to render stuff on my machine, but whatever. The rendering time is a night and day difference between what animators used for old movies such as Shrek. The rendering time is significant, says the DreamWorks head of research and development Jeff Wiki, because of the amount of work that goes into making an animated film. For a movie like Rise of the Guardians, there might be 100,000 storyboards. Freedom to change their mind. On some movies, DreamWorks might recreate storyboards 5 times because it wants to make sure that each letter in the story, each sequence and each specific scene it will render is ready to be digitized by animators. Yeah, quite big files. During another demo at DreamWorks office showing a scene from the movie Madagascar 3, an animator showed how he would experiment with Alex the Lion as he fumbles around the room. Wake says yeah. If you can imagine that totally for required, okay, specialist to experiment, we push every single out. I will say this. Next generation CGI. Oh yeah, let's see this. Why not? It's just a demo. Who would have thought that? Just a catchy title. Oh, this thing gives me an idea. Talking about the amount of objects inside the scene and the amount of polygons. This is important too. Oh wow, I was looking at this title, it really looks dumb. Okay. This is the article I used for photorealism in computer graphics. Oh yeah, so I should avoid I should avoid talking about, you know what, I will make, yeah, whatever. So I should avoid talking about papers and research and rather talk about the fact that right now graphics algorithms are harder to come up with, since we are already having algorithms based on reality itself. Yeah, I should mention that. Not here. The present times coming up with new graphics algorithms and techniques becomes increasingly harder, since a great amount of in the real world. The only this era for computer graphics is a fascinating one because it imposes a question. When will be the graphics cards so powerful and optimal? I don't want to say this word, but I forgot the word. You know what word I'm talking about because I wanted to say it above. So powerful and optimal that a human will not be able to perceive any difference anymore. And what will happen then? As Nvidia introduces ray tracing, real-time ray tracing for consumers. It is only a matter of time until graphics cards will be capable of I'm actually feel quite. I have no idea how to finish this script actually. How many pages do I have? Did I cross 4? Yes, I crossed well over 4. A lot of stuff will go all away. Will be capable of until graphics cards, until consumers GPUs will be able to render scenes with a great amount of detail. On the other side, having meshes words inside of games require a lot of work. I don't want to say this. On the other side, it appears that the more powerful, the more able average PCs are to render the games, the more work is needed. but there is a boundary where currently thousands of people are working on to bring great detail to games, but at some point, yeah, I want to write something here to bridge it, and then AI seems like a good solution to this problem. AI seems like a good option for adding detail to worlds and helping humans with this process. AI increases. Yeah, here I want to say, okay, this will be included in the final thing. And now I should talk. So now this should be above everything, along with this talk about and now in the today world's GPUs helpful for graphics anymore. On the other side, GPUs can it's actually really hard to write a script. I remember that the other were actually a lot easier to write because it required only me understanding a certain topic like Bitcoin or computer graphics, but this script is really hard because I need to structure stuff that I want to say in a specific order. And still it doesn't feel like research. This generation will be helpful in film industry too. Alright, so now that I'm skipping, but in the real time side of things, GPUs are capable to do more. Immersion is immersion, and now I such as and for creating immersion graph more fields than graphics are required. Audio is as important as graphics is, especially when considering the rather recent blow of VR technology. Coincidentally, at a basic level, sound and light are similar. Therefore, audio rendering sound audio can be handled. Just like and even as the case have been written for path-traced audio. Area. Not only this, but physics is another important area. And GPUs are not only this, but physics is another important area. And with technologies such as haptics devices arising, the simulation becomes necessary. I think this is well structured, but I will go through it again. This is the part that I need to do a lot of work on. Oh yeah, I have realized a thing. I don't have to discuss about GPUs themselves, but rather about how technology trends evolve, which is a really important thing, because I try to incorporate the word GPU explicitly So I think this part will be about after I'm saying I'm introducing this question. Yeah, I've introduced it and I am trying. Okay, I will I will extend this thing. Yeah, this I don't need to. I actually don't need to say this, but I let it there because maybe it will give me another idea. Yeah, how machine learning will help a lot of stuff inside this. I'm feeling like to take a break, so I will close this stream at this same exact moment. Hope you have enjoyed it. I'm sure no one watches it, but maybe someone will find it archived on YouTube, so I need to close it nicely. But anyhow, goodbye and good day.